Hi guys, welcome to another video of my YouTube channel. In this video we are going to see how to make a vase which you see in the cover image. So it's quite simple, but the process is much more like interesting for you to learn. So that's why I want to do this in Grasshopper and show you and explain you the process. So first thing first, let's go with the circle, and now let's say let's create a range, and let's say I want like a 10. Let's multiply this by 50, which what I can do is I can construct point. So usually I do it with move, but you can also do it like this way. So okay, you can see here, because we know we need just 10 value which has a multiples of 50 or 100 maybe, so that you can see here it has a multiples of 10. Okay, the maximum values will be the 100. So how do I say, when you multiply 100 is here the domain is 0 to 1, so 0 to 1, and you're creating 10 values, so 100 will be the, so it becomes 0 to 100, and you can either connect this 100 in the construct domain and do it. It's multiple ways to do the same step, sorry, I have the range, so let's say I want a graph mapper. Obviously my type is here, same thing, and you can either multiply or remap. It's up to your choice. I just multiply for now, so that I don't want to make it a little more complicated. So, and let's say I want I don't want okay, let me multiply this. Okay, something like this. It's your choice. Okay, you can work on it. Now let me divide the curves. So I'm going to, so this is the base base structure for the lamp, and now we are going to create that Lewis kind of structure in the lamp. So how can we do it? Let me divide it, maybe 30, I don't know, let me try. So we divided this and we got a value of 30. So but I don't want to be in the same size, I want to be in a different size, work in the different size. So what I can do is I'm going to create another graph mapper and connect the range here. Maybe let me try something else, some of the graph, why not? Let me try parabola. Nah, I was checking. Okay, let me try sine, why not? Why not? So now what I'm going to do is I'm going to, you can see here 30 points, one circle has 30 points, and each how do I say, each point of the circle is being stored in a single branch, branch 1, and each one branch. What I want is, let's say I want to create a circle, let's say 20. It's too much, sorry. Okay, but here in this case, if you see here, everything is same, but I don't want this. Let me say I want this first point in the circles should have 10, and the second should have 20. It has some graph inclination or something. So that's why I'm using this. I'm going to use this graph for let me multiply. So technically there is 10 branches because there's 10 curves and each, so I need to give a value for each branch separately. So technically what I'm doing is like I'm going to create like 2 for now. So I get like 10 value, I'm just going to graft it and I'm going to give the radius. So you can see here smaller, like bigger, blah blah. But if you want, what I prefer is like I make it like a decimal point, so it's more convenient for to the changes. Okay, now I want to see the circle, like the frame. So now what I'm going to do is like I'm going to cut this out. So this tool, okay, I'll just turn on the bifocal. I forgot to do it. So this is like a trim with region. Okay, like it trims with the region. So technically, like I'm going to give the curve. So there is like 30 curves. Just check the branch when you do it. Okay, because like if you see one single curve as like 30 circles, so the branch here. But here if you see like it is like a list of 11 curves which I want to be in single branch, but at the same time I don't want this connection to be like in a list, but I want so I can use graph tree separately, or you can use a curve parameter which stores the curve and you can use the graph here, or you can use the graph here connected. Like there's multiple ways to do the same process, like it depends on the approach. At the end of the day, if you get the output, that's cool. So let me say like I take the inside. So now we have the inside, and now like if you see here, you can see the size variation. I can show you. So you can see the sizes become smaller or larger, like based on the graph mapper, which is like just cool. Exactly. Wow, it's too small. Sorry, maybe okay, a little bit. And okay, yeah, okay, something like this. Like there's a lot of, you can work with it. Okay, so now we have this. So now we need to move this like outward so that we create this kind of connection, But to move it, like either you can like we need a vector, like we need a vector to like we need the direction. So for that we need a vector. So what I'm going to do is like I'm going to create a middle point over here, and I'm going to graph this obviously because this is a list, and I create a 2-point vector. 2-point vector. So vector usually gives me the direction. Sorry. 2-point vector. So vector usually gives me the direction, and so it usually gives me the, like, how do I say, it direction and the amplitude, or like the length, so which will be so cool. So I created the vector, and if you want to visualize, you can visualize it by using vector display. Like it's a component which visualizes the vector, but you just need to connect the curve. So you can see here what is happening here. Simplify. No. Okay. No, I just want to trim the tree because it created a subtree. Now you can see here. Yeah. So what happened is, like, when I create midpoint, so like here, if you see here, like okay, okay, the trim tree is over here. Okay, what happened here is, like, if you see here, it's a single curve, and like it has 30 circle which is going to cut. But when it gives me the output, it gives me every single curve into sub branch, which I'm not a fan of it. So I just need 30 circle, like 30 curves in a single branch. That's why you can either, like, you can connect this branch here and you can connect it over here. You don't need this. Okay, so you can you can connect this over here, and you get this, like, you get like this. So it's up to your call, like multiple like connections. Okay, now I'm just going to move this. Where is the curve? It's over here, and For moving, either you can use the vector and then multiply it, or like I'll just like use the, okay. So you can see here it's been moved outward, which I want like that. And but instead of amplitude, let me try like maybe I create another multiply from the same data range, and I'm going to use the same. 20 is too much, but yeah, I know it's too much. What I can do is I can just like 8. So technically I'm using the graph as the base proportion, and then I'm just multiplying it. So now we got like something like this. So what I'm going to do is I'm going to use these two curves. Okay, okay. No. I would say I'll just turn it off. What happens here? Why? Okay. Okay, there is like two components here, like you see here region and regions. So it is better to use regions to get like a proper. You can see here the output and input are like clearly visible. So I think yeah. So let me hide this so you can see the output separately. It's like it's a small change, but sometimes it goes with it goes like some other components as well. Just see like regions or curves, like you see the S of the multiple ways. Because like these components are nothing but a compile of coding in using Rhino common. So like when you work with multiple curves, the Rhino common, like the component works in a, like there is a separate component for that. So for certain components, like certain set of codings are there. So that's why. So I just use this. Let's see the mood one. Let me weave it. No, I just want to weave it like a knob. And let me create connect. I forgot the name of that. Sorry. Yeah, connecting curves. Actually, this one looks not bad, but I don't want. I want it to be like flat. So, okay, connectivity is like curvature, because like 0 is position, 1 is tangency. So position, yeah, position gives something like that. But even so, like connectivity looks cool, right? I like it. But yeah, not bad actually. But okay, I'll just try one thing with this as well. But right now, let's go with the position. Yeah, so it's cool. Now let's see the endpoint. Okay, this is like a scene. Like when I'm going to loft it, so just flatten this and loft it. Not bad, right? I just want to try one thing. Let me see if cap works. Yeah, okay, that's cool. And no, it didn't work. You can see the top is empty. It didn't work. It just only closed the pot. So what I can do is like okay. So in this case, let me say like list item, top and bottom, boundary surface maybe, and bit up join. I'll just show you what I'm trying to do. Like I'm just going to create a closed. Okay, let me bake. Wait a sec. Let me bake to see the cap. Yeah, it's capped. Okay, I just want to see one thing. Maybe I might be wrong. I didn't see it properly. I'll just like close this, delete this, bake. Oh, okay. Actually, cap works. Maybe visually it was like it didn't look like it was closed, so that's why I was. Okay, I need to check. Yeah, it's closed bit up. Okay, my bad. Sorry. Okay, now we got this. So what I'm going to do is like that's cool, right? So I'm going to take this asset again. You can see the curves are created. That's cool. Maybe what I can do is I'm going to like, I don't want to take that. I'll just offset this curves in obviously inside like minus x, and I'll just take again these two sectors, or I can use like, it's up to you. Maybe it's better to use this graph because this is the one which creates the basic curves, so it looks more proportional. And wait a sec, I don't need to be crafted. Okay, so you can see it's like it's going inside. So what I'm going to do is I'm going to create a loft again because it's not flattened. Sorry, I just reversed it. Loft works like it should have a list of curves, and I just cap it. So we have two solids right now. I'll just move this somewhere else. So what I'm going to do is I'm just going to cut it out so that you get like a, okay, this is what I was trying to do. Yeah, we got it. So we can like now we can change the, what is this, the moves here. Yeah, we can change it to 5, so that's less, and you can increase the number of points, like the lowest number of points is 40. You can see, so technically like it has that bump, like you can see. Maybe I can bake it, which looks much more, and you can see the closure here, which is cool, right? So that's all for the video. Let me bake this, and you can see like one is like this. You can change the graph and see some various output. And I'll just bake it. It's kind of even, you kind of waves, you can reduce the numbers, or else you can twist it. Let's try twist. Okay, geometry, and okay, I'll just take the first one, or list item. Okay, twist is nothing but like, okay, so what I'm going to give, like it asked me for the axis, so I'm going to give an area, and now SDL line maybe, direction, maybe I create a vector to play with it. Let me give a length so that $60. So wait a sec, I'll just I'll just put a shaded, yeah. What's this line, man? How tall I have just created this? I don't know. Sorry, like it's x-axis. It's just like, okay, I need to change the length here. My bad. I was wondering. I just gave the x. Yeah, sometimes, yeah. Some small things I just maybe don't mistake me. So I'm just going to create this like this, and now I'm going to divide curve. Again you will be like feeling why he is doing again, and I'm going to move it on unit x-axis, and now let's make it interesting. That's what I'm trying to do it. Range 20 multiply by 20. Yeah, okay, something like this, and I create an interpolate curve. So let me give this as an axis. Let's see what happens. Let me see. Okay, you can see it's been moved. Cool, right? I just hide everything off, and it asks me for an angle, let's say like 50, and I'll just do a degree. Okay, so technically I'm using that line as the axle and it's twisting based on that line. And so if you want, you can it's like just like how do I say, looks like an Harry Potter hat or something. Yeah, that's what, like if I want to work on it, like I'll just keep on going, which is not good. So you can see here. So like if you want, I will give you an exercise here. Like I created this. Now I'll just give you an exercise. Create a bottom, okay? Bottom for this. But after you create the bottom and after it joins, it should be a closed birp and it should not be open birp. So I'll just give you an exercise, something like this. If you want, you can give it a try and let me know in the comment section. Bye bye. See you in the next video. Have a good day. Ta-da.